Good morning to everyone. Myself, B. Krishna, Assistant Professor, Department of ECE. Today's class, I'm here with going to discuss about moving target indication. It is MTI radar and pulse Doppler radar. What is meant by MTI radar and what is the purpose of pulse Doppler radar? And what is the main characteristics of MTI radar here? All those things here I'm going to discuss in detail. So coming to introduction, till now we are required to detecting a target in the presence of noise. As you know, if the noise is available in the received signal at the receive station, the target detection is missed in the space. That is the problem is occur if the noise is present in the echo signal at the receive section. Okay, but in practical radar have to deal with more receiver noise when detecting a target, right? So here I want to go in point by point here. The first point, in radar system till now, discs were required to detect a target in the presence of noise, right? But the practical radar have to deal with more receiver noise when detecting a target. While they can also receive the echoes from the environment. The environment nothing but it is a land, is earth or it is a sea. These echoes are called clutter. Clutter means such as unwanted signals. Since those unwanted echo signals are tend to display with unwanted information. So with this unwanted information, so here the clutter echo signals has greater magnitude than the echo signals from the target. Okay. When an aircraft echoes and clutter echoes present in same resolution cell, it means the target may not be detected. The target may not be detected due to this unwanted information. So if this unwanted information is along with the actual echo signal, then the target may not be detected. Okay. But here we can also detect the moving target means the target is moving condition, that target is also be detected here. How it is detected, right? But based on this Doppler effect, it affects, this effect will be permit the radar to distinguish the moving target from the fixed target, even echoes from the fixed target than the moving target. It will be distinguish the moving target from the fixed target by using Doppler effect. As I told you in previous class, by using that Doppler effect, we can easily identify the moving target in the space. Coming to the MTI radar block diagram, let us see here. Okay, let us see here. This is the pulse modulator block module, power amplifier, mixer, stereo, coho, duplexer, and again mixer, IF amplifier, phase detector, and delay line canceller. Okay. Okay. Here, some of the modules as you know in previous classes. Okay, and here the pulse modulator. Okay, here the pulse modulator means it converts from the continuous wave radar into pulse radar system. And here the pulse radar system provides the pulse radar system providing a power amplifier and a pulse modulator. So by using this pulse modulator here, the power amplifier is going into turn on and off for the transmitting of or for the generating of the signals. So means, so here the pulse modulator is going into turn on and off the signal to transmit into the space, right? And here mixer, duplexer, as you know, here duplexer is performing both as a receiver section as well as it is act as a transmitter section. Okay. So coming to the here, the MTI radar is the radar which uses the concept of desired moving target. Why we go with this MTI radar means the major concept here, the main concept of this MTI radar is nothing but here we can detect the moving target from the stationary target. Okay. So here the main characteristics of this MTI radar is the transmitted signal must be coherent with the reference signal in the receiver. Must be the transmitted signal must be coherent with the reference signal in the receiver. Means the transmitted signal must be in phase. Okay. And here let us see the here the coherent nothing but it is a coho means coherent oscillator which preserve the phase of transmitted signal, right? A coherent coho means it is a coherent oscillator which preserve the phase of transmitted signal, and its frequency fc is used in receiver section, right? And here similarly the coherent oscillator is performing both, it serves the it serves its function both in transmitter as well as in receiver section. Okay. And here coming to the stallo means it is a stable oscillator. Stallo means it is called as a stable local oscillator with a frequency fl, right? And here the function of the stallo here it is to avoid the unwanted variations in the frequency, to avoid the unwanted variations in the frequency and to provide necessary frequency translation from intermediate frequency to radio frequency at receive section. Okay. And here this shallow is providing intermediate frequency signal to radio frequency signal. Okay. And also at the receiver side, at the receiver side here, the shallow it converts the radio frequency signal into intermediate frequency signal. Okay. So coming to the mixer here the stereo and coho are mixer in which they are combined. Here the stereo and coho and a mixer in which they are combined plus any low level amplification is called the receiver exciter because they serve the both transmitter as well as receiver. Okay. And here you know that the transmitted signal here it is a stable local oscillator frequency and a coherent oscillator frequency. Here again, this stable local oscillator performing it gives it combined with the mixer at the receiver section and also combined along with the coherent oscillator at the mixer at the transmitter section. And here the stable local oscillator frequency will be cancellation, and finally getting the mixer output is to fc plus or minus fd. So here the fd is nothing but Doppler frequency. Okay, the F is nothing but Doppler frequency. Next, here the shallow is it converts the The stereo means stable local oscillator. It's the RF signal heterodyne with the stereo signal to produce the IF signal. The RF signal means radio frequency signal. The radio frequency signal is heterodyne with the stereo signal to produce the intermediate frequency signal. Okay, intermediate frequency signal. So in intermediate frequency signal, intermediate frequency signal is nothing but here it is a amplifier. Here we can use the amplifier to strengthen the weak signal into strong signal. Weak signal into strong signal, right? And coming to the phase detector. And coming to the phase detector here. So here FC plus or minus FT is output of the intermediate frequency amplifier is given to the phase detector along with the reference signal. That reference signal is from the coherent oscillator. The main difference here it is in between the MTI moving target indication radar and pulse traffic radar is so here in the main distinct difference in these between these two, the MTI radar system is providing the reference signal at the receiver section. It was maintaining the in phase, in phase, right? And here, after giving this intermediate amplifiers frequency signal into phase detector and the coherent oscillator is given to the input to the receiver section to preserve the phase. Then the output of this phase detector is getting the Doppler frequency signal that will be given to the delay line canceller here. So here the delay line canceller act as a filter. The delay line canceller here act as a filter which allows the signal from moving target and reject the signal from the fixed target. It allows the signal from the moving target and reject the signals from the fixed target. That is the basic information about individual module in the block diagram of MTI radar system. So all those things here, I am going with the point by point. The first point here, it employing the power amplifier and difference between these MTI and pulse Doppler radar in which the reference signal is generated at the receiver section, right? And here the stallo means is a stable local oscillator with frequency FL. The function of stallo to avoid unwanted variations in the frequency, right? It can be provide the necessary frequency translation from intermediate frequency to radio frequency signal at the transmitter section, as well as it converts the radio frequency signal into intermediate frequency at the receiver side. That is the function of the stable local oscillator. That means but it is a stallo. Coming to coherent oscillator is a coho means it is a coherent oscillator. It preserves the phase of transmitted signal and its frequency. FC is used in the receiver. It preserves the phase of the transmitted frequency signal at the receiver. So whose frequency is the same as the intermediate frequency used in the receiver. Okay. Here, the stallo, coho, and mixer in which they are combined plus any low-level amplification is called as a receiver exciter because they serve both transmitter as well as receiver. Okay, so here antenna. As in already you know that the purpose of the antenna here, it can be performing both transmit radiate. It can be performing both transmitter as well as receiver. So whatever we can signal, we can whatever we are transmitting the signal, those signals are transmitting into the space by this antenna. And if any target is available in the space, if that is if it is a moving target or fix a target. Those echoes are reflected back, and such signals are received the same antenna here. Here, the duplex is going to performing both actions, such as transmitter action, and receiver action. Okay, so this transmitter action, receiver action will be going on depending upon this pulse modulator. Pulse modulator. This pulse modulator is going to turn on and off the transmitter section. Okay. This is the basic information about the moving target indication radar, how it is, why it is, and what are the difference between MTA radar and pulse Doppler radar, and what is the purpose of pulse Doppler radar. Okay, this is the basic information about the MTA radar system. Thank you.